everyone, we're going to solve the following inequalities, and it goes from easy to hard. I will also be graphing these in one-dimensional graphs, and I'll also be using set notation and interval notation. So set notation should look like that. Interval notation will look a little different. Alright, so let's do the first one. So the first thing, this one's pretty easy. We're just going to subtract 1 from both sides. So we'll get x is less than 4. And all that means is if you graph it on a number line, and this is 0, and this is 4, it means that it can't equal 4, so we do an open interval there, and it's all values less than 4. So 0 is less than 4, negative 3.999 is less than 4, 3.999 is less than 4. And so your set notation looks almost like that. You just put x such that x is less than 4. Interval notation, you're just looking at this. This is negative infinity, and this is infinity. So interval notation is we're going from negative infinity and use open interval. This would be closed, but we're using open, comma, and we go to 4. And this is going to be open as well because it can't equal 4. If it could equal 4, then we would have used that. Infinity is not a number, so you can never equal it. So that's interval notation. And it's your solution, and this is set notation for your solutions. Alright, the next one is this one, a little harder. So let's go ahead and just distribute that. That's going to be 1/2 x minus 1/2 of 4 is 2 is greater than x plus 8. I love getting rid of the parentheses. Now, I'm going to go ahead and let's see, if I subtract x from both sides, that's 1x. I get negative 1/2 x. And then if I add 2 to both sides, I get is greater than 10. So I subtracted that out. 1/2 minus 1 is negative 1/2, and I added the 2. That cancels, and you get 10. Now what we're going to do is multiply, let's see, let's go ahead and multiply everything through by 2. So 2 times 1/2 is just, negative 1/2 is just negative 1. And 2 times 10 is 20. Now we want to solve for x, not negative x. So let's go ahead and multiply everything through by negative. So I'm going to, or negative 1. So negative times a negative is positive. But when you multiply by negative, you have to flip that sign. And then we have negative 20. Alright, because you're just multiplying it through. So if you graph this, let's say we have 0 here, negative 20 here. This is not drawn to scale. It's kind of like the last one we did. It can't equal negative 20, but it's all numbers less than. So this is going to negative infinity. This part's going to infinity. So set notation would be x such that x is less than negative 20. And interval notation would be negative infinity. It would be all of this to negative 20. And it can't equal 20, so use your open interval. Okay? And then the next one is this one. What we want to do is we want it to look like this. Some number here. We want x to be in between two numbers. So let me move this. Whoops. Let me move this over here. I want it to look like this. Let me do it again. So to get it to look like that, first thing I'm going to do is subtract 4 from every piece. We have 3 places to subtract 4. You just do it on either side of this sign. So When you do that, these 4's cancel, which is what we wanted. So you get negative 9 is less than or equal to negative 3x, which is less than or equal to negative 2. All right, now to get x by itself, we divide everything by negative 3. And what happens is when you're dividing, like we did on the other one, dividing or multiplying by negative 3, not when you're adding or subtracting, that's fine. But when you're multiplying or dividing by negative, you have to switch these signs. So negative 9 divided by negative 3 is just 3, and flip that sign. This cancels, so you just have x. Flip it again. This is going to be 2/3. Now this is not a good way to write it, so I'm going to reverse it and write it this way. 2/3 is less than or equal to, because if you read it right to left, that's what it would say. 2/3, if I'm reading it this way, 2/3 is less than or equal to x, and then here x is less than or equal to 3. So I'm going to go ahead and graph that. I have a 0 here. I have, let's say this is 2/3, and I'll call this 3. Now it can equal it. See the equal signs? So I colored the intervals in, and it's all these numbers. X is in between 2/3 and 3. Again, this is negative infinity to infinity. So the way you write it is set notation would be x such that x is in between 2/3 and 3 inclusive, because we're including the endpoints because of the equal sign here. Interval notation would be closed interval because we can equal it. So it's 2/3, comma 3. So those are the two ways to write your solution sets. And that's it. Thank you. Have a nice day. Bye-bye.